So in this video, we're just simply asked to find where the tangent is horizontal to this function's curve. In other words, if we're going to take the derivative of this, we can find out where there is zero change in position. Another way of stating that is just simply finding out where there is no positive or no negative slope. So that said, let's go ahead and start by just finding the first derivative of this function. And we'll write this as the derivative y with respect to x. And by now in your homework, hopefully you can just simply take the entire derivative as a polynomial string. So we'll just rewrite this function. And at this point, you might realize that you really don't even need to bring down the positive 1, as our constant rule states that the derivative of a constant is always going to be 0. And this is not exactly right. Let's move that over. Okay, now we have the correct notation, and we will find the derivative is going to be, well, 3 times 2, that's 6. And then x to the third minus 1 is going to leave us with 6x squared plus 2 times 3. Well, that's 6 again, but this time it's 2 minus 1. Leaves us with 6x minus, and this is the x to the first, so we have 1 times negative 12, leaves us with negative 12, times x to the first minus 1. Well, that's x to the 0, which is 1. 1 times 12, still 12. So we have our derivative. At this point, what we need to do is set it equal to 0, because we are trying to find zero slope. Where the horizontal tangent lines are exactly where there is no slope, no change in position. So we will take this derivative function that we just found and rewrite it a little bit differently. So we'll set it equal to 0. As you can see, each term has each term is divisible by 6, and sorry, I always forget if it's least common denominator or greatest, but anyway, we're going to factor out a 6. And we're going to have 6 times x squared plus x minus, well, 6 times 2 is 12, so that's where that'll leave us. Don't need to worry about this because 6 equal to 0, not really. So that's just 0. And we will just worry about what's on the inside here. And what we have is polynomial, let's see, x squared plus x minus 2. So we're going to set this as 1 times negative 2. And in the middle, we have a positive 1. And we need to find out what two numbers, when multiplied together, give us negative 2. Well, probably a 1 and a 2 and a negative somewhere. Since we have a positive 1, we need to make the 1 the negative. And then we can set this up as x minus 1 times x plus 2 is equal to 0. Now we can set these, because they are products, factored out, we can set those equal to 0 individually. So we have x minus 1 equal to 0 and x plus 2 is equal to 0. Add 1 to both sides here. We end up with x equals positive 1. Subtract 2 from each side, and we end up with x is equal to negative 2. So they're just asking us what are the points. So they're not asking us to actually find a horizontal tangent line, which would mean find the slope, find the equation, point slope formula. So it's just the points. So what we can do is we can take our x of values that we have found and plug them into our original function. And I won't bore you with the math. We end up with a point of 1, and y is -6. And we end up with a point -2 and 21. Looking at the graph of Pollock-Desmos, you can see that we are correct that for this graph's function of curve, at this point of -2, 21, that is where a change happens from a positive increase to negative increase. That would be a horizontal tangent line right there through that point. And then down below at 1 and -6, again, that's where another horizontal tangent would appear. So I hope that helped. Thanks for watching.